I'd like to attempt to discuss something called the twin paradox. The idea is that we have two twins, exact same age. One of them gets into a rocket ship, blasts off to go a very far distance near the speed of light, and comes back. When he comes back, the guy that blasted off, went to the distant planet, and came back, is younger than the one that stayed here. Let's put some actual numbers to that. Let's say that the rocket travels at 0.6 times the speed of light. No, let's make it 0.8 times the speed of light. And let's say that the distant planet is 4 light years away. Well then, the time it takes the rocket to get from Earth to the distant planet, that's delta t over 2. That's going to be the distance divided by the velocity. That's 4 light years, also known as speed of light times a year, divided by 0.8 times the speed of light. That's going to be 5 years. Takes him 5 years to get there, 5 years to get back. The twin that stayed has aged by 10 years. But now the question is, how old is the twin that went? Well, delta tau, the time on the rocket that went there and came back, is just the square root of 1 minus v over c. V over c is 0.8 squared times 10 years. 1 minus 0.8 squared is 0.64. 1 minus 0.64 is 0.36. Square root is 0.6. This ends up being 6 years. So the twin that went on the rocket has only gotten 6 years older, much less than the twin that stayed home. Now I hope that right now you're saying, wait, hold your horses. You said it was 4 light years away, and yet he only aged 6 years, which means he went a total distance of 8 light years in 6 years. That means his speed, 8c years divided by 6 years, is 1.33 times the speed of light. He's been traveling faster than the speed of light. That seems wrong. And it is. The problem is, this distance is the distance as perceived by us at rest with respect to the Earth and the distant planet. When he's in the rocket ship, the planet seems to be rushing at him, and the distance between him and the rocket and the planet is shortened. So the distance he sees will simply be the square root of 1 minus 0.8 v over c squared times the 5 light year distance. But this is just 0.6. In other words, the distance he travels is only 3 light years, and I've done something. Oh, I found my mistake. The total distance isn't 5 light years, it's 4 light years. So I have 0.6 times 4. From his perspective, he's only traveled 2.4 light years. 2.4 light years in 3 years is exactly 0.8 c. So he measures the exact same speed, and it's still slower than the speed of light.